Today we're going to look at logarithms and graphing logarithms. This is new, and I don't think that you've ever seen these before, so I'm going to give you some definitions, and you'll want to highlight these because you'll need to memorize these definitions of how we go from logarithmic form to exponential form. But basically, we've been dealing with exponents, and now we're going to be dealing with logarithms. So logarithm of y with the base b is what we're going to look at is an exponent. Okay, so what does that mean actually? Well, let me give you a logarithmic form. We have a y equals, we have a logarithmic is abbreviated log. We're going to have a little subscript b. This is going to stand for base. And then we have what's called an argument. And this is brand new. We've had some exponential form. So let me show you how we take a logarithmic function and change it into exponential. So what do each of these stand for? B stands for base. X is what we call the argument. Y, I don't know, that's what we just call it. And if you think of this y, think of this as the exponent. Okay. So watch when we translate a logarithm into exponential function. This is how we'll translate it. B is going to be our base. Whatever's on the other side of the equal sign is our exponent. And what does this equal? It equals x. So the first thing that you're going to have to do is just get comfortable with looking at logarithmic functions and changing them to exponential and vice versa. Okay, so make sure that you put your x and y and b all in the right spot. The only one that really probably makes some sense is this b. And then the way I try to keep it in mind is this thing on the other side of the equal sign is my exponent. So watch when I translate 1a. So looking at this, this is log the base 2 of 8 equals 3. Means what? 2 is my base, 3 is my exponent, and this equals 8. So translate. This little number on the log is my base. My exponent is on the other side of the equal sign, and this equals a 1. So once you translate, let's just make and see if it makes any sense. So 2 cubed is equal to 8. You should know that. Anything to the 0 power equals 1. So the first exercise that we're going to do today is just translating so you can get familiar with the logarithmic form. So when we do that, we're going to try exponential to log and then log to exponential. So let's try an example 2, how we write our first logarithm. So I'd say 12 squared equals 144. That's correct. So we write log. My base is 12, so you just kind of come down a little bit and write your 12. Remember, on the other side of the equal sign is your exponent. So your exponent goes on the other side of the equal sign. Your base is the base of your exponent, and then what's left is what goes into the argument. So the base can be anything. Exponents can be positive, negative. So how am I going to translate this? I'd write log. I just move down a little bit and put my base. I like to put my equal sign first. And on the other side of the equal sign is where our exponent goes. And what's left is the argument. And that goes in that slot. So I'll give you some examples of what's called common and natural log. Common logs are used a lot in science. So we have a special notation for common logs. because sometimes in math we don't like to write out everything. So if we have a base of 10, it's customary to leave that 10 off. So if you see a log, just an log, what you have to know is the base is there, but it equals 10. So let's take a look at 4b first. So I don't see any little number here. So to translate this to exponential, the base, it's not there, so I'd put it there. The exponent is on the other side of the equal sign. And what does that equal? That equals 1/100th. To write logs, I would put log the base b, and the b is 10, but since it's common, we don't have to put it. The exponent we put on the other side of the equal sign, and this we'll just write as our argument. So the idea with the log with nothing there, there is something there, but what you have to know is that the base is actually equal to a 10. And another well-used logarithm is what we call a natural log. And a natural log is a log to what we call the base e. And remember the other day we looked at that e, and remember what e is. E is just a number that's an irrational number that goes on for forever and ever. So if you see an ln, you're going to have to know that this is a log to the base e. And you might not see it there, so let's take a look at 6. Example 6, notice that doesn't even spell log, but it has natural log. So you're going to have to know that this means the base is e. Remember, the other side on the equal sign is our exponent, and this equals 404. To write a log, one way to do it is to say log the base e. So I would go down here and put a little e there. Put your equals, and this is where your exponent goes. And what does that equal? We'd put 20.085. We run out of room there. And for our argument. And again, this is where we'll use a shorthand. So when we see log of base e, as mathematicians, we will just get rid of that and just write ln, or say the natural log of natural log 20.08. What does that equal? That equals a 3. So one of the things that I'm going to have you do today is just to get used to notation. And I want you to go back and make sure that your definitions are good, and make sure that you know where to put b, and where do you put x, and where do you put y.